2 of the BJU textbook in Algebra 2, talking about sums of polynomials. So before we begin, with defining a polynomial. So a polynomial is an expression that has one or more terms. So we're going to talk about what a term is in just a little bit, but know that a polynomial is built out of terms. Here's an example of a polynomial. So notice that you've got different variables with different exponents on them. That's how we know that they are different terms. They are split up by subtraction and addition. Okay, so 6x squared is one term. We're not going to split the 6 and the x squared up. They actually became one term, 6x squared. However, when we have this plus 9x, 9x is not part of the 6x squared term. So all the terms are going to be divided up by the subtraction and the addition symbols, operations. Okay, so there are 1, 2, 3, 4 terms in this polynomial. So very important for a definition of a polynomial, you're never going to have negative exponents on your variables. You will never have negative exponents on your variables. Also, your variables will never, not your variables, your exponents won't be fractions. Now you can have fractions in your polynomial. That's okay. You could have 1/5 x. That's fine. But you would never have x to the 1/5. Your exponents would never be a fraction. In the same way, since we know that x to the 1/2 is the square root of x, then that means that we would never have a square root or a cube root or any type of root in a polynomial either. You could have a term that doesn't have a variable in it. For example, 24 doesn't have a variable, but it's still a term. It's still a term. 24 is a term. All right, so let's go ahead and go a little bit deeper and let's talk about what terms are. So remember, terms are what make up a polynomial. So terms make up a polynomial. They're building blocks of polynomials, if you will. So terms are the addends of the expression. Remember, the definition of addend are the different parts that make up an addition problem. So for this one, for the definition of polynomial, we had terms that made up the polynomial. So it's the addends of the expression. Terms can be made of variables and numbers. A combination, it could just be a variable, it could be just a number, or it could be a combination of numbers and variables. And when we say combination, we mean multiplying and dividing, like 2x. 2x is a combination of a number and a variable, but we're really multiplying 2 times x. So here's an example of different types of terms. You have x3, which is an example of a term with just a variable. You have negative 2x squared. So notice how I say the negative with the term because the subtraction was right before it. So negative 2x squared, that's an example of a term that has a combination of a number and a variable. And note that it's written with multiplication, so 2 times x squared. We have plus x. So that plus x is just a variable by itself, and then plus 4, the 4 is a term with just a number. So next word, coefficient. Coefficient is the number that's multiplied by the variable. So every single variable is going to have a coefficient, whether you see it or not. So for example, x cubed has a variable or has a coefficient in front of it. You might say, well, there's not a number in front of it. Well, that's okay because anything times 1 is itself. So really, the coefficient in front of x cubed is 1. There's an invisible 1 in front of that x cubed. The negative 2x squared. So the coefficient in front of that is actually going to be -2. So remember, the subtraction goes with what it's right before. So -2 would be the coefficient of that term. Then we have 3 as the coefficient for the next term. And then for the term of 4, the coefficient would just be 4. Let's talk about classifying polynomials. So the first way to classify a polynomial is the number of terms that polynomial has. The second way to classify a polynomial is the degree of a polynomial. So again, there are 2 ways to classify polynomials. The first way, how many terms. Second way, the degree of the polynomial. So let's talk about number of terms first. So I showed you how to count up the number of terms. Remember, terms are separated by plus and subtraction, addition and subtraction. So once you count up the number of terms, you can classify that type of polynomial. If you only have 1 term, you have a monomial. So here's an example, 21x squared y. So notice that there's no plus, there's no addition, there's no subtraction. So if you have 2 terms in your polynomial, you have what's called a binomial, bi meaning 2. And then an example of that would be 5x plus 2. So 5x is your first term, 2 is your second term, so you've got 2 terms, so you have a binomial. Trinomial is exactly 3 terms, so tri meaning 3. So an example of that would be 9 minus 6y plus xy. So notice that there are 3 separated terms there. All right, so before we can classify a polynomial by its degree, we first have to know how to get a degree of a term. So the degree of the term is the sum of the exponents of the variables in that term. So it's the sum of the exponents of the variables in the term. So just in the term, we're just talking about the degree of a term right now. We're not necessarily talking about a degree of a polynomial yet. So here's an example. We've got 10x to the 6 y cubed. So the exponents right now, we have an exponent of 6 and an exponent of 3. So our degree of this term is going to be 6 plus 3, which is 9. So for this term, we have an exponent of 5, 2, and 3. So that means that our degree of that term would be 10. So for this term, you might think, well, this is a degree of 3, right? Because that's the only exponent you see. But remember, anything to its first power is itself. So technically, this x is to the power of 1. So it has an exponent of 1. This z is to the power of 1, which means that it has an exponent of 1. So 1 plus 3 plus 1 is actually 5. Let's try another one like that. So we have got 2 plus the invisible 1 plus 3, which gives us a degree of 6. All right, so you try this one. What is the degree of this term? Okay, you should have gotten 12 because 5 plus 6 plus 1 is 12. What about the degree of this term? Okay, so 4 plus 2 plus 5, it should have gotten you 11. All right, now that we have gotten really good at getting the degree of a term, we can now figure out how do we get a degree of a polynomial. So, because remember, a polynomial is built up of terms. So the degree of a polynomial is its highest degree term. So if you will get the degree of every term in that polynomial, the highest degree is that degree of your polynomial. So in this example, you've got negative 4x squared plus 2x 2y cubed minus 5z4. So the degree of your first term is 2, the degree of your second term is 3, and the degree of your third term is 4, which means that 4 is the highest degree term, so the degree of your polynomial would be 4. You go ahead and try this one on your own. What is the degree of this polynomial? Okay, so the first term has a degree of 5, the second term has a degree of 6, and the third term has a degree of 4. And since 6 was the highest degree term, the degree of your polynomial is going to be 6. Okay, go ahead and try this one now. So the degree of your first term is 5, the degree of your second term is 4, and your third term actually has a degree. If you don't see a variable, remember that anything to the 0 power is 1, and your variable disappears. So for example, x to the 0 power is 1, and then 1 times 1,000 would be 1,000. So you really have this invisible x to the 0 power in that third term. So that means that your degree is 0 for that last term. So that means you've got 5, 4, and 0 for your degrees of terms in that polynomial. So the highest degree term is going to be 5, which means that your polynomial has a degree of 5. All right, let's move on to adding and subtracting polynomials. So very important is to remember is that all we have to do is combine like terms. That's all we're doing. When we're adding and subtracting polynomials, we are combining like terms. So remember, like terms are things that have the same variables, and those variables also have to have the same exponents in order to be combined. So for example, you could not combine x and x squared. That's illegal. Can't do that. However, you can combine xy and xy. That's 2xy. That's okay, as long as you have the same variables in each term, and as long as those variables have the same exponents in each term, you can combine them. And when you combine those like terms, you're going to not change the variables and not change the exponents. The only thing you're going to change is the coefficient, which is the number in front of the terms. And you're going to add those coefficients or subtract those coefficients. So again, like terms have the same variables and exponents. So let's look at combining this, okay? So you have to follow order of operations. So you might have remembered PEMDAS, right? Where the P stands for parentheses or groupings, right? So we have to get rid of the parentheses before we subtract. So when we get rid of the parentheses, we have to use the distributive property. So we have to distribute this subtraction to each term inside the parentheses. So negative 3x squared, negative times 3x squared will become negative 3x squared. Negative times negative 7x is going to become plus 7x. Negative times negative 4 is going to become plus 4. So when we get rid of our parentheses, the first set of parentheses just drop, right? Because there was just a plus 1, so everything stayed the same. However, this was a minus 1 right here that we distributed. So we get the minus 3x squared and the plus 7x and the plus 4. So when we combine like terms, well, 4x squared minus 3x squared. So remember, the x squareds, those are the same variables with the same exponents. So we're going to combine the coefficient. This is a coefficient of 4, and this is a coefficient of negative 3. So 4 minus 3 is 1. So we get 1x squared. Remember, we don't actually have to write 1 in front of x squared. We can just write x squared. So next term, 8x. The like term with 8x is going to be 7x. So we're going to combine the coefficients. 8 and 7. 8 and 7 is 15, so we get 15x. Notice that my variable did not change. I just combined the coefficients. My next coefficient is 9. 9 has a like term of 4, and 9 plus 4 is 13. This is all you have to do. You cannot combine anything else. You cannot combine x squared and 15x because the variables, even though it's the variable x, the exponents are not the same, so you cannot combine them. All right, go ahead and try this one by yourself. This one is adding, so you don't have to distribute a negative. You don't have to change any of the signs. You just have to combine like terms. Go ahead and see if you can get this one for yourself. All right, so if you combined 5y squared with 4y squared, you should have gotten 9y squared. And then if you combined 3y with negative 3y, well, 3 minus 3 is 0. So your y term actually disappeared. So it was your options 3 and 4 are now gone. Then you combine negative 2 with 1. Negative 2 plus 1 is going to be negative 1, which leaves you the answer, option 2. Go ahead and try this one. So if you have 9a cubed and you want to combine something with 9a cubed, you need a term that has the variable a with an exponent of 3. Before you can do that, however, you have to distribute this subtraction to eliminate the parentheses. So it becomes negative 2a cubed plus 6a and negative 3. So 9a cubed minus 2a cubed becomes 7a cubed, which knocks out option 1. Then you have 3a and a negative, so plus 6a becomes 9a. So that knocks out option 4. Then you have negative 4 minus 3. So negative 4 minus 3 is negative 7. So you end up with option 2. Go ahead and pause the video and try this one on your own. Remember to distribute the negative first. All right, so my first term is a 9. So in order to combine anything with this, 9 does not have a variable. So unless another term does not have a variable, I can't combine it with 9. And I'm looking at all of these terms, and all of them have variables, which means that 9 cannot be combined with anything. And that's okay. That means that 9 is still in my answer. My next term is negative 3y. So I'm looking for a term that has the variable y, just the variable y with no exponent. So negative 3y minus y gives me negative 4y. My next term is xy. So here I'm looking for another term that has the variables x and y, but don't have any exponents on them. So I have this over here, so xy minus 6xy is going to become negative 5xy. So it looks like that's going to be option 3 or option 4. So my next term that I have by itself is this minus negative 2x, which leaves me plus 2x, which gives me option 4. Option 4. Go ahead and try this one by yourself. Notice that this plus 1. The 1 kind of went over to the next line. So just so you know. And remember to subtract, to distribute the subtraction first before you combine like terms. Go ahead and pause the video and try that one. Alright, so 5y squared minus y squared is 4y squared. Then you have 6y minus negative y is going to be 7y and plus 7y. So I actually don't have to go any further in this multiple choice. I know my option is 3.